Welcome back, Physical Science 20. So we continue on with the stoichiometry questions. So we've looked at mole to mole type, and here we'll look at the final type here. Basically it's the same thing, except instead of starting off with given how many moles and moles of a reactant, we're given grams and grams. So once you've identified the limiting reagent, you can predict the mass of the product using the strategy outlined previously. So if I look at this example, methanol can be made by using the synthesis reaction involving carbon monoxide and oxygen. Here, determine the limiting reagent when 9.80 grams of carbon monoxide and 1.30 grams of hydrogen reacts. So with the last questions, we wrote the number of moles on top, and we're going to do the same thing here. So really we just have an additional step at the beginning, and that is to simply convert each of these into moles first of all, and then we can compare the mole ratio given the equation. Here you can see it's a 1:2 ratio, so we need to figure out how many moles of each we have here. So of course, to do that, very similarly to what we did before, to change grams into moles, we have to figure out the molar mass of each of these. So carbon monoxide, we're going to have to figure out the molar mass, and hydrogen, we're going to have to figure out the molar mass there too. Now, since if you read on here, what mass of methanol can be produced? So we're going to have to, again, figure out how many moles of methanol, and then change that back into grams. So we might as well figure out the molar mass of methanol as well, because we're going to have that later. So just like previous unit, figuring out the molar mass here, figure out the molar mass of each element, and then adding them all up. So carbon's 12.01, oxygen 16. So the molar mass of carbon monoxide, 28.01 grams per mole. Hydrogen, 2 hydrogens, each of those is 1.01. 2.02. 1 carbon, let's see, 3 plus 1 is 4 hydrogens. 1 oxygen. It's 12.01 plus 4.04 plus 16. So that's going to give me 32.05 grams per mole. Okay, so that's the initial phase. So we're going to figure out how many moles of this we have, how many moles of this we have, and then we can compare those two values just like we did in the previous part to figure out which one's going to be limiting. So here, let's start with this. Figure out 9.80 grams is how many moles. So 9.80 grams of carbon monoxide. And according to this, carbon monoxide, there's 28 grams per mole. So we were going from grams to mole. So on your blue sheet, of course, you can look at that. Or you can see here, grams to moles. So obviously we're going to have grams on the bottom and moles up top to get what we need. 28.01 is 1 mole. So we're always using this. We're not using this mole relationship yet. So that gives us 0.3498 moles of CO. Do the same thing over here. 1.3 grams is what? 1.3 grams of H2. And again, the molar mass is 2. Now be careful here. I see some people make the mistake of they see this 2 here and they want to put a 2 on top of here. Well, no, it's molar mass, grams per 1 mole of H2. So yes, you always know if you're doing it right, if you can cancel off the units, and of course molar mass is always per 1 mole. So 0.6435 moles of H2. So there we go, we have the moles. So basically what we've done here is that we've turned this question into the types of questions we've been doing. So 0.3498, 0.3498, and 0.6435. 0.6435. Now we're ready to compare those two items. So again, we can pick one, and you'll get to a point where you can just simply do one step, but I like to do two steps just to prove that one works and one doesn't. So let's start off here. If I try to use up all that 0.3498, do I have enough? So 0.3498 moles of carbon monoxide, and according to this, of course, 1 mole needs 2 moles. 1 mole needs 2 moles of hydrogen. 1 to 2. 1 to 2. So that's going to give me 0.6996 moles. I'm just writing a few digits here, not rounding off just yet. And if I'm going vice versa, 6435, 0.6435 moles of hydrogen. And according to this, 2 mole needs 1 mole. 2 moles need 1 mole. So then we have to figure out, well, which one works. So if I'm looking at the first one, if I try to use up all the carbon monoxide, I need this much hydrogen. Do I have it? No, I don't. I only have 0.64. I need 0.69, so that tells you that one doesn't work. So this must mean I'm going to be using up all of the hydrogen instead. 0.6435 requires 0.3218 of carbon monoxide, and I got way more. I have a 0.349. That one works. So used up. Therefore, oops, limiting reagent is hydrogen. So I end up using up, because I can use up all that because I only need that. So the question doesn't ask to figure out excess carbon monoxide, but we could figure that out by taking what we have, 0.3498, subtract what we're going to use up and get their excess. But the question doesn't ask for that, so we don't have to worry about that. So this is limiting, and this will be excess. All right. Next, so we figure out what the limiting is, what's going to get used up, and then we can use that to figure out what we're going to get produced here. So we're going to use our limiting to figure out how many moles we have, and then convert that into grams. All right, so let's do that. So we're going to be using up all of our hydrogen. So our, excuse me, 0.6435 moles of hydrogen. And if I'm going from moles of hydrogen to moles of what we're trying to find out here, which is methanol, 2 moles produces 1 mole. 2 moles produces 1 mole. Now if I was to stop right there, I would have how many moles of methanol I have. But of course I want to go one more step, change it into grams. So that of course uses the molar mass calculation right over there. For every 1 mole of methanol I have, that's equivalent to 32.05 Gs. 32.05 Gs of methanol. And again, look at that. Cha-ching, cha-ching. Moles and moles, so I'll end up with grams of methanol. So when you type that all in, 0.643 times 1 times 32.05 divided by 2. Don't have to worry about that one. I think we get 10.31208 Gs. If you look at our original question, 3 sigs, 3 sigs. So we'll round that off to 3 sigs. So 10.03 grams of methanol produced. So hopefully you didn't run out of room in that, because that's quite a lot there. But hey, we have 2 more examples to work through. Why don't you start the next one, and then tune into the next video, and we'll go through that one. All right, we'll see you again.